Alright, well, I hope what we realize now is that if we're trying to factorize something and that there are three terms involved, the first thing we look for obviously is a common factor, and that's something we really should always be looking for. It doesn't matter how many terms, doesn't matter what type of factorization you think you might be doing, just always look for a common factor, because that might allow you to use other methods of factorizing you might not see otherwise. But if we have something like this, b squared plus 10b plus 25. Well, this is the type of method where we have three terms. Now we notice there's no common factor between all three, so we can't go and do our splitting up method or anything like that. So we are looking for terms that have a sum of 10 and a product of 25. Well, this one's actually pretty nice because I can think of a pair of numbers that multiply to give 25 and add to give 10. If you'd like to pause it and have a think about what numbers those might be, do that now. But if not, I think those numbers are 5 times 5 and 5 plus 5. Okay, now it just so happens that our numbers are the same. There's nothing wrong with that. Now, of course, we factorize that one as b plus 5 and b plus 5. Now, there's actually a special notation we use for this. The notation we use is we say it's b plus 5 all squared. Now, what you might recall is when we did those expansions, we literally just worked up the ladder here. We started here with these expansions and said, well, I can rewrite b plus 5 all squared as that, and then I can go and expand it to that. So that's the notation we should use. Technically, if you write it with this notation here, you're not wrong. It's just sometimes this one is a little bit easier and simpler to use. So let's have a look at another one of these. Okay, let's say I've got something that looks like this. I've got n squared minus 8n plus 16. Alright, again, I'm looking for numbers that multiply to give this and add to give this. Okay, well, let's look at a pair of numbers. What numbers multiply to give 16? I've got 16 times 1. I've got 8 times 2. I've got 4 times 4. Okay, well, because I notice here that I've got this positive sign, but I've got this negative sign, that tells me something a little bit interesting. And what that tells us is that if I've got a negative here, a positive here but a negative here, it means what I'm going to have is a negative multiplying a negative. So my two numbers are going to have to be negative. If we had a negative, if that was negative 16, well, then we'd be looking for one negative number and one positive number. But in this case, we are looking for a pair of negative numbers. And if we look at our possible options here, well, I can't say minus 16 and minus 1. That will give me minus 17. Not correct. I can't say minus 8 and minus 2 because that would give me minus 10 in the middle. That's wrong. We're getting closer though. And if I use minus 4 and minus 4, the same two numbers, well, then we'll end up in the right place. So that factorizes to n minus 4, n minus 4. And that notation that we use is n minus 4 all squared. Okay, let's have a look at one harder one. What if I've got something that's got a negative factor that looks like this? I've got minus y squared plus 3y plus 4. Okay, well, I think our issue here is this negative. Now what you'll notice is each time we factorize something simple, like, well, not that this is simple, but the simpler versions of these, we've never actually dealt with that sort of situation before. So if we're going to deal with something that has a negative coefficient of our square term, my suggestion is to do this. Straight away, just take that negative factor out the front. Really what factor we're taking out is negative 1. But what that means is we just change the sign of everything else. Okay? So we don't just drop the y squared and forget about it and pretend it's not there. What we do is we take it into account. We account for it by removing negative 1, put in blue there, and 1 as a factor. So now what we can do is, let's just keep that minus out the front here, that -1 out the front, and say, well, this is one of those ones that's going to factorize using a pair of numbers. Now I've got a pair of numbers that multiply to give 4 and add to give 3. Now of course what we're looking at is -4, so really our options are, in terms of what factors I could use 2 times 2 or 3 times 1. Now obviously because I've got a negative number there, I'm going to have a positive and a negative number in my brackets. Well, straight away I look at that and say, if I was to have a +2 and a -2, well, I'm going to end up with 0 in the middle, so that's wrong. So I know I'm looking at 3 and 1. It's just a matter of getting which one right. Well, what I see is, pardon me, it shouldn't be 3 and 1, it should be 4 and 1. So because I have -3y, I'm going to have y minus 4 and y plus 1. Now that's how we fully factorize that expression there. Don't get concerned about this negative out the front. We just take it into account. We take it out as a common factor.